Okay. Can you see my shared screen?
Opo.
Okay. So actually for today, we are down to our last topic on aqueous equilibrium. Okay. For aqueous equilibrium, we covered acids and bases up until solubility equilibrium. For the last part, check lang natin. Or before we go to the last part, let's check what we discussed from our previous meeting. Yung last topic on acids and bases was on buffered solutions, if you remember.
Opo.
Okay. And remember, buffered solutions are simply just a mixture or a solution of an acid, a weak acid or a base, and its conjugate. Always remember that you can only form buffered solutions from weak acids or weak bases. Okay? You can't make buffered solution from strong acids or strong bases, given the fact that they react completely when dissolved in water. Okay? So yung property which we observe in which there is no significant change in pH from addition of small amounts of strong acids or strong bases, we can only observe that from buffered solutions. Okay, and then remember the Henderson-Hasselbalch equation. Okay, and then our last topic for aqueous equilibrium is on solubility equilibrium. Okay, naalala pa yung for this topic, you have to consider the solubility rule. Okay, naalala pa ba from your previous lessons?
Opo.
Sige nga, bigay ka nga ng three rules. Solubility rules na naalala mo.
Naalala ko lang po kasi yung ano yun. Wait lang po.
Let's start with the soluble solids. Ano yung tayo na soluble salts?
Nitrate and nitrite, lahat soluble. Sulfate.
Okay, so that's one. They are all soluble. Kahit anong kasama nilang cation, they are soluble. All nitrates are soluble.
Sulfate except barium sulfate are all soluble, I think. Or where ba?
What about which group of metals yung always soluble in their ionic forms? In their salt forms?
Alkali metals po.
Alkali. So yan, isa yan sa pinaka-basic din. You always have to remember that all alkali metals, including ammonium salts, are soluble. Okay?
And
What about chlorides?
chloride, lahat po except silver chloride.
Okay. For halides, actually, the rule is generally for halides, not just for chlorides. So this also applies for chlorides, bromides, iodides, and sometimes fluorides. Si fluorides kasi minsan medyo iba yung behavior, pero kasama din si fluoride. Okay? All of them are soluble except for silver salts of halides.
Bakit po?
Silver mercurous, Hg1, and Pb2+. Always remember this three.
Bakit po
Okay?
ganun?
Yan yung mga insoluble halides.
Meron ba po silang something na makes them insoluble?
Actually, for that case, it's mainly because of the interaction ng mga ions. Okay? Pero it's outside of our scope. Just always remember na for this three, silver ions, mercurous ions, and lead ions, they are all insoluble if we are talking about the halides. Okay? They're halide salts. Okay? And remember, itong Hg22+ is mercury 1. Okay?
Abo.
So for this topic, we will be talking about insoluble solids. Okay? And solubility equilibrium refers to the equilibrium reaction involving the dissolution in water of a partially soluble ionic compound. Actually, take note of the term used here. Okay? Instead of calling them insoluble, we call them partially soluble or sometimes sparingly soluble salts. Okay? Because the thing is, they are also soluble, but to a very limited extent. Okay, some of the solids gets ionized, but most of it actually remain as a solid form that settles down in the solution. So kung kunyari you have a container with water, and then you add, let's say, sodium chloride. Based on solubility rule, this is
Very soluble.
very soluble, okay? And you know also from experience that this is very soluble, okay? Syempre, sodium chloride, very example, is rock salt, di ba? If you place it in water, it will get completely dissolved. So for that case, ano siya, mag-homogenize siya. But if you add another salt, let's say silver chloride, um, for sodium chloride, the dissociation is sodium ion and chloride ion. If you add another salt like silver chloride, you'll notice that some of it will actually just settle down at the bottom of the container. Okay? Pero, magdi-dissociate din siya. Silver chloride will also dissociate, forming silver ions and chloride ions. Okay? But again, based on the properties of these partially soluble salt, the dissociation is only to a very limited extent. Okay? Now, we can also describe this process based on an equilibrium expression. Okay? So there is what we call solubility product constant. We symbolize this as KSP. Okay? Ano lang siya, special symbol lang din for an equilibrium constant KC. Remember, for the acid dissociation, we use Ka. For base, we use Kb. For the solubility of partially soluble salts, we use KSP. Okay, this is the solubility product constant. Okay. Now, if we have, for example, this salt given by M, this is actually a Greek letter. Pero don't mind the symbols, basta ano lang yan. This is just the subscript for the cation, subscript for the anion. Okay?
Bakit po parang,
So,
bakit po parang medyo, ano po, medyo, complex po yung pagkano ng subscripting procedure.
ano lang to. Actually, for general chemistry textbooks, hindi ganyan. Mas madali siya. Pero if you read some physical chemistry textbooks, ito yung mas ginagamit nilang notation. Kasi when we derive some expression, we will be needing numbers for the stoichiometric coefficient. So we have to differentiate the charge from the stoichiometric coefficient. Okay?
Apo.
Pero ano lang yan, symbols lang yan. Kahit ano, actually, kahit anong symbol pwede mong ilagay dyan eh. The thing is, kailangan lang naiintindihan. Okay? Pero, ano lang to, meron lang akong ginamit na reference from a physical chemistry textbook. Ganito lang yung ginagamit nilang symbols kasi merong mga complicated derivations na usually sobrang daming terms na lumalabas. So yung paggamit ng ganitong symbol is easier to distinguish the terms. Okay? Kasi minsan pareho nung number. Pero yung number pala comes from the charge and not on the stoichiometric coefficient. Okay? Minsan may mga ganong case. So you have to differentiate na ito pala ay galing sa stoichiometric coefficient at hindi pala galing sa charge. Although they are related, okay? Pero ano lang to, medyo maarting way lang ng pagsulat ng reaction. Pero definitely you can easily follow this Kasi if for example, you have dissolution of silver chloride, you can just easily write it down as this its dissociation into silver ions and chloride ions. So this term here is only just 1 for silver ions. Itong term na to is also just 1 for chloride kasi pareho namang 1 yung stoichiometric coefficient. And then the Z plus is plus 1, Z minus is negative 1. Okay? Ganun lang naman siya. If you have another salt that is also insoluble, let's say, ano bang lead chloride. Okay? If you dissolve this in water, most of the salt will settle down in the container. Hindi siya madidissolve. Pero some portion of it will remain, will dissociate into lead ions, 2 plus with a 2 plus charge, and 2 chloride ions. Okay? So yun lang naman. You can easily just write down the reaction based on the stoichiometric numbers. That's clear? Now, this dissociation reaction, we can also describe it using the concept of equilibrium. So to track down the changes in concentration, we also use the ice table. Okay. The only difference is for the salt part, for the ionic solid, you don't have to write anything. Okay. Aside from water, there's also no need to worry about the concentrations at any given moment for the insoluble solid, because they are solid in form. Yay for now, okay? Pero medyo mas komplikado sa solubility kasi if you'll notice, it's not just a one-to-one dissociation reaction. For example, lead chloride, it produces 3 ions. Tama? It produces 3 ions for every 3 moles of these ions for every mole of the salt. Tama? Usually kasi for acids and bases, it's a one-to-one dissociation. It's always just one proton na umaalis dun sa acid o kaya one proton na nare-receive na base. Kaya mas madali yung stoich. Dito, definitely, we have to be careful with the stoichiometry of the reaction. Okay? So, let's do some practice exercises. Okay? Now, calculating KSP from solubility. Okay? Actually, for this case, if you'll notice, ito lang yung values niya. Itong value na to is just the stoichiometric coefficient, right? Now, for every salt, usually there is, aside from the KSP value, aside from the solubility product constant, there is also what we call solubility. And yung S, notice na instead of X, we actually use S. Okay? Kasi yung S na value dito also refers to solubility. Okay? And this is usually expressed in molarity. Okay? So moles per liter. And this solubility, expressed in moles per liter, refers to the amount of the salt in moles per liter of the volume, per liter of the solution that gets dissolved in your solution. Okay? That's why it's called solubility. Okay? So you just have to solve for S and yun na yung solubility ng compound. Okay?
Hindi lang po siya yung ano nito. Talagang it is a real significant meaning.
Ano ulit? Sorry?
Meron na po talaga siyang meaning other than ito po yung mag-change lang.
Actually, for ano din naman, for acid dissociation, X is the H plus concentration, right?
O kaya OH minus.
Although most of the time kasi, for acids and bases, we are mostly concerned with pH calculation, sometimes pOH, but mostly pH, right? For this case, usually, ang hinahanap natin ay solubility. Okay? Or for this case, pwede rin KSP, given the solubility of the compound. Okay? Now, let's look at this practice exercise. solid silver chromate is added to pure water at 25 degrees Celsius. And some of the solid remains undissolved. Okay? By the way pala, if you are doing some experiment in the lab, let's say for example, you want to calculate for solubility, if you do your experiment, you have to make sure na merong solid sa ilalim. Okay? Kailangan may ma-observe kang solid. Kasi mamaya, you add some salt, tapos lahat na dissolve. Kasi hindi pa pala nare-reach, hindi pa pala nasa-saturate yung solution. Okay? Kasi yung solubility, yun yung saturated concentration niya. Yun na yung maximum amount that can be dissolved for a given volume of the solution. Okay? Actually, I think yun yung better way to define solubility. Solubility refers to the maximum amount in moles, usually in moles, of the solid that gets dissolved, that can be dissolved in a given volume of the solution. Okay? Of course, also for a given temperature, kasi solubility is also dependent on temperature. Okay? If you increase temperature, definitely solubility will increase. Okay? So you need to make sure when you do your experiment na may solid. Kasi baka mamaya wala pang solid, hindi pa pala saturated. So maybe you can get some number that is less than the actual solubility. Okay? Now, the mixture is stirred for several days. I don't know if this is an exaggeration, pero this is also to make sure na saturated yung solution.
Ito po yung,
Okay?
ito po dapat mas mataas po yung binabayad sa kanya.
Well, depende. What if everyday naman kailangan niyang mag-work? So, iwan mo lang yung setup, pwede naman yun. To ensure that equilibrium is achieved between the undissolved silver chromate and the solution. Okay? So analysis of the equilibrated solution shows that its silver ion concentration is 1.3 times 10 raised to negative 4. Sorry, this is in molarity. Okay. Sorry, this is my fault. Lagi kong sinasabi, huwag kalimutan yung unit para nakalimutan ko siyang isulat dito. Also, maybe you may want to change or to correct yung nandun sa copy mo ng slide para lang hindi ma-mislead. But this is expressed in molarity. Okay? So, calculate KSP for this compound. Okay? So, how do we do this? Sorry, mag-add ako ng slide kasi I need
Oh no, it's the copy-paste.
Hindi ko na siya. Copy ko ba? Yes, I think kailangan ko pala siyang i-copy.
Imagine copying po when you can just manually write it.
Ayan. Meron na tayong space for the calculation.
Sinender pa po graphic designer.
So for this, first, you have to write down the dissociation reaction for our salt, for our sparingly soluble salt. So this is silver chromate solid. Okay? If we dissolve this in water, some of it will dissociate into silver ions and chromate ions. Okay? This is in aqueous form. This is in aqueous form. Okay? Also, take note, meron ka ditong 2. Okay? For the stoichiometric coefficient. That is very crucial when you do your calculation. Now, if we construct the ice table, again, there's really no need to worry for the concentration of the solid at any given instant. Okay? Just make sure na merong undissolved portion doon sa solution. Okay? Now, initially, there should be no silver ions and chromate ions present in the solution. Okay? Kasi pure water natin siya dinissolve. For the change this should be plus 2s, and this is plus s. Right? So at equilibrium, this is equal to 2s, this is equal to s. Okay?
Opo.
Now, KSP expression is properly written as concentration of silver ions squared. Ito you have to be careful on this. Kasi I noticed nung sa chemical equilibrium na portion natin, minsan nakakalimutan yung yung exponent. Okay? I mean, I know you know this,
Opo.
pero minsan nakakalimutan lang siya.
Extreme po na ano po yan kasi pag square. Ibig sabihin, pag na square root po yung nilagay niyo pong na reagent, baka sumabog.
Kaya nga, minsan sobrang crucial nung change dun sa calculation, di ba?
Opo.
And then, equilibrium concentration for the chromate ion. So this is just equal to 2s squared and then s, which is equal to just 3s, sorry, bakit ako nag-3? 4, sorry, 4s cubed. Okay?
Suspicious.
Okay.
4s cubed.
Now, for this, the solubility, actually for this case, S is equal to 1.3. S is equal to, or the silver ion concentration is equal to 2S. Okay? What is the silver ion concentration for this? It's 1.3 times 10 raised to negative 4.
Muntikan na po yan, muntikan. Muntik na po.
Actually, napansin ko din. Okay? And you also have to be careful. For this problem, yung given na equilibrium concentration ay kay silver ion. If it's the chromate ion, then whatever concentration is given, yun na mismo yung solubility. For silver, it's different kasi obviously from the reaction, di ba, for every mole of silver chromate dissociating, you produce 2 moles of silver. Okay? Kaya yung solubility ng compound should be equal to S equal to 1.3 times 10 raised to negative 4 over 2. So you have to divide it by 2 pa. Okay? Kasi dalawang silver ions ang nagpo-produce for every mole of silver chromate dissociating. Okay? So what is the solubility of silver chromate?
Something. 6.5 times 10 to the negative 4. Negative 5.
Sorry, it's 6.5 times 10 raised to negative
5 po.
Negative 5 molar. Actually, this is also expressed in molarity. Okay? Now, to calculate for KSP, we just have to substitute the value of S here. So, KSP is equal to 4 times 6.5 times 10 raised to negative 5 cubed. This is equal to
Something. Bakit? Okay. Naka-cube. Times 6.5.
Tama ba? Tama ba yung calculation ko? Ay, yung expressions?
Grabe ang liit 1.0985 times 10 to the negative 12 po?
Actually, wag kang magulat kasi for most salts, for most insoluble salts, ganyan kaliliit yung mga values. Ano ulit yung value?
1.095 times 10 to the negative 12 something.
Times 10 raised to negative 12. Okay? Common yan. Common values for solubility for KSP times 10 raised to negative 8, times 10 raised to negative 10, negative 12, etc. Okay?
Grabe ang liit po nung madidissolve din po.
Okay. Is this clear?
Opo.
Okay. Actually, if you'll notice, if you have a salt na sabihin nating MX, yung form, if this dissociate, it forms M plus X minus. Okay? So, ang KSP nito, this is equal to S squared. And solubility is just equal to square root of KSP. Okay? If you have M2X, like the case of silver chromate, you produce 2M plus X2 minus KSP. This is equal to 4S cubed. And S is just equal to cube root of KSP over 4. Okay, actually, may pattern siya kung manonotice mo.
Dapat ay
If
mas
you have...
gagawa po ako ng gagawa po ako ng table tapos I will find the pattern. So I don't have to
Actually, meron siyang table. Usually sa solubility, may ganyan na table. Okay, I'm not sure kung nilalagay siya sa general chemistry textbooks. Pero I think if you'll search online, may makikita kang table ng relationship between solubility and KSP for different salts with varying stoichiometry.
ito po yung
Okay?
ito po yung the gift of technology.
Pero naman, syempre, hindi naman kailangan silang kabisaduhin. The goal here is for you to understand how it works. And yung idea lang naman is just based on the concept of equilibrium and using the ice table. Okay?
Ayun, may po may
But, nakakita ka ng table?
parang may po may relationship.
Yes, meron siyang relationship. May pattern siya. Meron siyang pattern. Pero take note na yung pattern na yan only works for pure for solutions in pure water. Okay? Kasi kapag may common ion effect na, hindi na siya, mag-iba na siya. Okay?
Opo.
So for pure water lang siya. Now let's do another example. This time, we need to calculate KSP. We need to calculate solubility. Okay? Given the KSP, which is the usual case. Kasi for most salts, if you look at textbooks, Gen Chem textbooks or Anachem textbooks, you can easily find KSP values. Okay? Ito, tingnan mo yung KSP values, Joshua, from this table. Aluminum hydroxide, 3 times 10 raised to negative 34. Imagine how insoluble aluminum hydroxide is. Okay? So the dissociation...
Di ba po nag-form po siya ng gel?
Yes, actually. Aluminum hydroxide is a very common reagent used to form hydrogels. We call it hydrogels.
May tawag po pala po yan.
Pero depende kung anong klaseng gel yung pinoform mo. Usually, magandang gamitin si aluminum hydroxide for hydrogels. Because of the hydroxides, kasi maganda yung interaction niya with water. Pero, take note, KSP, it's 10 to negative 34. Okay? Pero also think of it na yung KSP is based on the dissociation of the salt into its ions, cations and anions. Okay? Kasi maybe some may argue na but si aluminum hydroxide maganda naman yung interaction niya with water. Okay? Kahit maganda yung interaction niya with water, yung KSP values na to is based on the dissociation for aluminum hydroxide, for example. It is based on the dissociation into aluminum ions and hydroxide ions. Okay? Laging ganun yung equation. I-split mo yung cation and anion. Okay? So yun yung hindi mataas yung tendency. Kaya yung KSP value niya sobrang baba. Okay? And if you'll notice, the smaller the value for KSP is, the less soluble the compound or the salt is. Okay?
Opo.
Okay. Okay. Now, another example. So, calculate the solubility of lead sulfate and lead fluoride at 25 degrees Celsius. So let's just do lead lead sulfate kasi direct lang to eh. Actually, pwede mo nga kunin agad yung lead sulfate eh. Kasi lead sulfate, this is 1:1. So, it's just the square root of KSP.
Yay!
Diba? Tama ba? Nasundan niyo
Opo.
yun?
Na, it's
Okay.
time, dapat gagawa po talaga ako ng comprehensive na pattern for the so I don't, kahit na absurd pa po yung yung,
Yung
yung,
mathematical relationship.
kahit na absurd pa po yung kasi baka, somehow magkaka 9 po na coefficient, basta makaka-survive.
Wag naman. Pero actually, I don't think aabot sa ganun.
Opo.
For lead fluoride, this is the dissociation reaction. So for the ice table, nothing here. 0, 0, plus S, plus 2S. So this is S, this is 2S. So KSP is just equal to 4S cube. Okay? So yun, kunin mo lang yung KSP ni lead fluoride, which is 3.6 times 10 raised to negative 8. Solubility is just equal to cube root of 3.6 times 10 raised to negative 8 over 4. Right?
Ano na po, this is big brain time.
Nasundan ba yung expression?
Opo. Ngayon pala, kala ko
Okay.
po parang, but yung sanayito ko pa yung practice set, what is this? Na ano na po, nagpanic po ako eh.
Pero ngayon, nag-make sense na ba siya? Nag-make sense na ba?
Opo.
Okay, good.
Wait a minute. Nag-ano po, there's still another unlock, there's still another lock na portion of the problem.
Sa practice set na to,
Suspicious po yung second part ng 5.
tinignan mo yung number 5.
Opo, very suspicious.
Mamaya, we'll see.
Meron po pong, is there any actual ionic solid na never dissolves at all, does not dissociate at all?
Actually, I don't think may ganun. Kasi definitely, pag may humiwalay na ions, that's already dissociation, di ba? And down to molecular level or down to ionic level, I don't think merong isang compound na completely intact when dissolved in water.
RIP.
Diba? I mean, I don't know. Tinisip ko lang siya. Parang hypothetically, parang ang impossible naman na meron kang ionic compound, tapos nilagay mo siya sa water and kahit isang ion, sabihin natin, wala man lang nakumalis from the ionic structure, 'di ba?
Opo.
So I don't think possible. I am not sure though. Pero halos lahat naman ng tinatawag natin na insoluble salt, they are really soluble. They also dissociate, pero sobrang liit nga lang. Okay? And actually, sobrang liit talaga. Notice the values for KSP, di ba?
May isa nga po, parang yung silver sulfide po, negative 48.
8. Diba? It's insanely very low. What is solubility for lead fluoride then?
Lead fluoride is negative 8. So,
Sorry, hindi ko man.
lead fluoride is it's not 1:1, oh no. It is an MX2. This is an I have to start writing.
Actually, ito na siya, oh.
Literally. When I've been fooled. 4 divided by I have an idea po. Instead of going through all of that hassle, shift solve.
But actually, hindi siya ganun kagandang idea din. Kasi minsan mabagal mag-solve si calculator kapag ganun.
2.08 times 10 to the negative 3.
0.08 times 10 raised to negative
3 po.
3. Okay. Is this clear? This is expressed in molarity for solubility. Okay?
Opo.
Okay. Actually, for this case, we need to express it both in molar concentration and in grams per liter. Pero definitely, you can do this. We just have to multiply the molar solubility in or with the molar solubility here is mole per liter of lead fluoride. So if you want to express solubility in grams per liter,
We get it's the molar mass.
yes.
I don't have the periodic table. No, I have to try the web to the whatever that website is.
Silver is, hindi ko rin kabisado. 127? 127 ba si silver?
That's yun po talaga yung yun po talaga yung memorization. Even I don't remember the
Actually, hindi naman siya kailangan. Ako, hindi ganun kaganda yung memory ko eh. So, hindi ko rin kabisado yung mga values. Pero, ikaw, I think, okay, Joshua, I think magiging helpful if you know the molar masses of common ions, of common elements.
Obo.
Siguro sa sa representative elements, yung group 1, group 2, tapos halides, tapos yung mga nasa harapan, first, second row ng P block. Sa D block, kahit yung first row, second row, mga ganyan. Tapos yung mga common heavy metals like silver, gold. Yan.
Obo.
Kasi very very frequent na kailangan yung nila, molar masses nila.
Obo.
So what's the solubility? Ano yung molar, molar mass ni lead fluoride?
Okay. 235.2 grams per mole. Genius. So, multiplied. Wait. Yes, multiplied by this. Which is 0.51 halos po. 51 grams per liter. Medyo malaki rin po yan
But that's 1 liter
Yung meron po kaming 1 liter na parang bote po eh.
Wait lang. Let's double check. So it's 3. Anong molar mass ni silver fluoride?
What is the molar mass of silver? This is the price I pay for when I forget the periodic table. Fluoride. Huh? Oh no, I forgot the spelling.
Ay, sorry. Bakit silver fluoride? Ako yung may kasalanan. It's lead fluoride pala.
2.4 ay, nakalimutan ko po eh. Parang may na 245.2 grams po.
245.2 grams per mole.
Opo.
Lead fluoride.
Opo.
245. Ano lang siya, 0.51.
Opo.
Tama ba?
Baka mali po yung na... RIP. 2.08 times 10 to the negative 3 times 245.0. 0.51, bro. I've been, nakalimutan.
Careful.
Nalagay ko po negative 2 sa, exponent. Oh,
Kaya nagtaka din ako eh. Sabi ko nga no, parang ang laki ng 51 grams. Kasi if I do it in the lab, parang ang mabigat yung 51 grams ha. Madami-daming salt yun. Okay. So only 0.5, ano lang, half a gram. Okay? Only half a gram can be completely dissolved for a liter of solution. Okay? So, ibig sabihin, if you do your experiment, if you add, kunyari, you have 1 liter water, if you add 0.2 grams, most likely, lahat yan dissolved. Okay? So, kung dissolve siya lahat, hindi mo ano, or kung dissolve siya lahat, if you test it, it would appear na parang mas mababa yung solubility niya. Pero, ibig sabihin talaga nun, hindi pa na-saturate yung solution. So, you have to add some amount greater than 0.51. Kailangan ma-saturate yung solution para ma-test natin yung maximum amount na ma-dissolve. Okay? And based on our calculation, the maximum amount is just 0.5 grams for every liter of the solution. Okay?
Opo.
Is that clear?
Opo.
Okay. Now, actually, last part, this is, we also have to consider common ion effect for the solubility of this partially soluble salts. Okay? And the same thing na pinag-aralan natin sa chemical equilibrium, diba, the presence of common ions will affect the equilibrium position. For this case, it will push the equilibrium back to the reactant side. Okay? Kasi if you have a salt, let's say MX, you dissolve it dissociate into M ions and X ions. If X ions or M ions is already present in the solution, di magkaroon ng common ion effect, it will push the equilibrium from right to left. Okay? So what will happen to the solubility? It will decrease. Okay?
Opo.
Meaning, for example, lead fluoride, the solubility of lead fluoride in pure water is higher compared to the solubility of lead fluoride in a sodium fluoride solution. Okay?
Opo.
So, lead fluoride is also more soluble in pure water than in a solution containing lead nitrate. Okay?
Opo.
Nitrates naman are soluble. So, lahat nung nilagay mong lead nitrate, dissolve yun. Pero dahil may lead ions na na-present, being common to lead fluoride, itutulak niya equilibrium pabalik. Nitrate ion is just a spectator ion. Okay?
Opo.
So, how do we do this? In calculation, kapareho lang siya ng sa ice table, except that for the initial concentration, meron na siyang certain value. Okay? Kung ano man yung value na to. Okay? Kung sino man yung common ion na salt. Okay?
Opo.
Actually, depends sa time, pero I think meron naman tayong example dun sa practice set. So maybe we can work on that. Pero for now, ito muna yung tingnan natin. Kasi it's more of descriptive lang.
Ito na po yung parang combined.
Yes. Ano lang naman to, i-describe lang natin ano yung magiging effect dun sa solubility. Okay? So for the pH effect, which of these substances are more soluble in acidic solution than in basic solution? So A, we have nickel hydroxide. Nickel hydroxide is a partially soluble salt. Saan siya mas soluble? Sa acidic solution or sa basic solution?
It looks like a basic solution because of the OH.
Actually, lagi mo lang tandaan yung Le Chatelier's principle, and tandaan mo lang din na sa equilibrium, hilahan lang yan. It's like a tug of war. Okay? Tug of war siya, tapos kung saan ka nag-add, yun yung mas mataas yung push. Kapag mas nabawasan, dun mas madaling hilahin. Okay? For example, for nickel hydroxide, the dissociation is just nickel ions. This is the formation of nickel ions and 2 hydroxide ions. Okay? Now, take note that if you have a basic solution, okay, let's say you have two solutions, one basic and the other is acidic. In terms of hydroxide concentration, definitely mas mataas ang hydroxide concentration nito. For an acidic solution, mababa ang hydroxide concentration. Tama?
So, dapat balik-baliktad po pag acidic, gusto niya nasa basic, tapos pag basic, gusto niya nasa acidic.
Actually, for this case, it happens lang na merong common ion. And the common ion is hydroxide. Right? So for nickel hydroxide, if it dissociates, it produces hydroxide ion, which is common to a basic solution. Actually, common siya kahit sa acidic solution. Ang difference lang talaga, mas mataas significantly ang OH concentration in a basic solution than in an acidic solution. Right? Okay. Now, if OH minus is already present in the solution, what will it do to the nickel hydroxide solubility? Will it increase or decrease the solubility? May hydroxide na present dun sa solution. Nag-add ka ng nickel hydroxide. Ano mangyayari sa solubility? Will it ito muna pala. Before we compare acidic and basic, let's compare solubility of nickel hydroxide in pure water and in a basic solution. Okay, pure water and basic solution muna. If you dissolve nickel hydroxide in pure water, ito siya, yung dissolution. Okay? Pag pure water, normal lang, nasa normal range yung OH and H+. But if it's a basic solution, may significant increase na ng concentration ng OH. Initially, bago mo pa i-add si nickel hydroxide. Right? So, saan mas mataas ang solubility ni nickel hydroxide? Is it in pure water or in basic solution?
Siguro mas mataas pa yung solubility pag nasa pure water. Kasi pag nasa basic po, maglalaban na po yung OH, it will rather be in nickel hydroxide than in very unbalanced na po.
Yes. Dahil may presence na ni hydroxide ion, itutulak niya pabalik. Right? Common ion effect, Le Chatelier's principle, right? Okay. Is that clear? Okay. Now, let's compare the solubility of nickel hydroxide in pure water and in acidic solution. Okay. Pure water, acidic.
Kung nasa acidic po kasi, it's almost impossible na magkakaroon na OH. Baka siguro konti lang po yung, very, very little po yung concentration ng OH. So, the OH is free to roam. Pero sa tubig po, meron pa...
So, saan mas mataas ang solubility? In acidic solution or in pure water?
Acidic solution po. I think.
So for nickel hydroxide, solubility is highest in acidic solution, lowest in basic solution, Tapos, sakto lang. Right in the middle for dissolution in pure, in pure water. Okay? Actually, ito pa, Joshua, gusto ko mas makita mo siya na ganito. If you have an acidic solution, meron diyang presence ng H+, a significant amount of H+. Okay? And when H+ meets OH, it can actually react to form water.
Opo.
Ano yung K value nitong reaction na to? Do you know?
Key value of the reaction.
Of this reaction. The reaction between H+ and OH-.
Baliktad ng autoionization eh. So,
Okay. So what's the K value then?
1 times 10 to the positive ba or negative? Negative, 14 pa rin. Same pa rin po, I think. Or...
What happens to K if you reverse the reaction?
Magre-reciprocate kasi po yung K. So, instead of the negative 4 to the negative 14, it will become to the positive 14. Taas po na ng K
Now, imagine this value, 10 to the positive 14th. Sobrang taas nung reaction. Sobrang taas nung constant. Equilibrium constant nung reaction. Actually, for this kind of reaction, the reaction is almost complete.
Opo.
Okay? Kaya nga, di ba, if you'll notice, para sa dissociation ng strong acids and strong bases, hindi tayo nag-report ng K value kasi the value are very, very large. That the reaction is actually complete. Ganon din for the reaction of H+ and OH- forming water. Okay? Nasa 10 to the 14th yan. Okay? Almost complete yung reaction. Okay? So, anong mangyayari kapag merong presence ng H+, ng significant amount ng H+ dun sa solution? So, imagine nickel hydroxide, you dissolve it in an acidic solution. The moment na mag-dissociate si nickel hydroxide into nickel ions and hydroxide ions, kukunin ng H+ si OH.
Opo.
Kapag kinuha ni H+ si OH, mafe-feel ni nickel hydroxide na nababawasan yung product ko. So paano siya mag-a-adjust? Kailangan niya ulit itulak yung equilibrium, right?
Opo.
So mapupush yung equilibrium forward. Clear?
Opo.
So dahil napupush yung equilibrium forward, mas tumataas yung solubility. Okay? Remember Le Chatelier's principle, kapag nagdagdag ka ng common substance, kailangan ma-consume yung dinagdag. Kapag nabawasan yung substance, kailangan ma-form pa yung substance. For this case, habang nagdi-dissociate si nickel hydroxide, nawawala ulit yung hydroxide kasi kinukuha ng H. So dahil kinukuha ng H, lalo pa siyang magpo-produce. Okay? Clear yan. Is that clear?
Translucent.
Pero nasusundan mo yung hilahan ng equilibrium.
Opo.
Questions?
Wala po.
Sure. O, letter B.
Letter B.
For calcium carbonate,
Ito po.
saan siya
Meron po
ma-soluble?
akong experience dito. I just don't want to know why I did. Yung CaCO3 po, parang basic po siya eh. Yung basic po siya kahit nilagay na lang po sa tubig. So, it's almost sure na it will be better in an acidic solution.
It will be more soluble in acidic solution. Okay?
Opo.
Bakit?
Because it's basic itself. It produces OH.
Actually, for this case, I want you to look at the reactions. I mean, pwede yan na klase ng tawag dito, ng explanation, pero mas gusto ko na makita mo paano nag-interact yung mga ions. Okay? And then bakit ito yung mas favored na direction ng reaction? Okay? For this case, we produce calcium ions and carbonate ions. Now, si carbonate, remember, it can actually react with H plus to form bicarbonate, and pwede pa rin hanggang carbonic acid. Right?
Opo.
Okay. So, tandaan mo, kapag merong possible na equilibrium reaction, pwede rin siyang mangyari. Okay? So, kapag ito nangyari, nababawasan yung carbonate. Right? Pag
Opo.
nag-react si carbonate kay H+, mababawasan to, mapupush ulit siya forward. Okay?
Opo.
Hindi naman siya pwedeng mag-react kay hydroxide. So, yun yung reason kung bakit mas soluble si calcium carbonate sa acidic solution. Okay? Actually, aside dito, kapag ito, nagtuloy-tuloy yung reaction, si bicarbonate nag-react ulit sa H plus to form carbonic acid, pwede mag-dissociate, pwede mag-disintegrate eh. Pwede mag-disintegrate si carbonic acid. Oops.
Kasi ano po siya, unstable po siya eh. So, may H2O tsaka CO2 na po.
H2O and CO2. Tapos, as a gas, pwede siya mag-escape dun sa solution. Tama. So, pag nag-escape siya, lalong nababawasan pa yung concentration ng carbonate. So, lalo pang mapupush yung reaction forward. Tama.
Ito po talaga yung epic na mangyayari po sa ano. It's a chain reaction.
Yes. Actually, ganun siya. Ganun mo siya tignan. Hindi lang for the case of calcium carbonate, pero maraming cases sa equilibrium reaction na chain reaction siya. Now, pag sinundan mo yung reaction, saan siya papunta? Okay? And ano yung gusto nating tignan? Dahil ang concern natin ay yung solubility ng calcium carbonate and alam natin na itong mga reactions na to are possible to happen. Kapag ito nangyari, lahat yan magre-result into greater or higher solubility for calcium carbonate. Okay? Kasi lahat sila magle-lead sa pagkawala ng carbonate ion. So dahil nawawala, magpo-produce ulit si calcium carbonate.
Abo. Yun po yung ultimate solubility. Talagang it's not just going to dissolve, it will disappear.
Yes, actually for this case, kasi pwedeng mag-escape out of the solution yung mga carbon dioxide eh, right?
Abo.
Clear yan, nasusundaan?
Opo. Ngayon po yung next example, I have no idea kasi I don't know yung nature ng mga to.
Then okay lang, for this case, ano mo lang, kahit tandaan mo lang actually yung mga basic reactions, or actually tandaan mo lang yung mga common na substances. Kunyari, barium fluoride. So, pag solubility, lagi, ito naman yung reaction. Barium fluoride forming barium ions and fluoride ions. Now, ang isipin mo lang, how do they interact to H plus or OH minus? Usually, kapag metal ions, halos hindi naman sila nagre-react. Okay. Actually, nagre-react din sila. Pero, hindi, nagre-react sila. Sorry, mali yung term ko. Nagre-react sila, pero usually interactions lang, electrostatic interactions lang, but not really a formation of a certain substance. For fluoride, for example, it can react with H plus to form HF. Okay? And take note, HF is a weak acid.
So it won't
Okay?
dissociate.
So dahil weak acid siya, gusto niya ding mag-form, gusto niya rin mag-exist as molecular form doon sa solution.
Opo.
If it's a strong acid, ayaw niyang mag-form ng molecular form. Tama. But HF is a weak acid. So okay lang sa kanya if nasa molecular form siya. Meaning, if H plus reacts with fluoride ion to form HF, okay lang na ma-retain tong form na to ibig sabihin, mas mataas yung tendency na mabawasan yung fluoride ion. Right? Okay. So, anong effect na yun? For barium fluoride, saan siya mas soluble? Acidic or basic?
Acidic.
Sure?
Kasi kung basic po, inisip ko po, yung OH naman, baka mag-form na BeOH po, di ba? Pagka OH.
Actually, barium hydroxide is also insoluble. Kapag nangyari yun, mababawasan din ng barium ions. Pwede rin mabawasan ng barium ions. Pero ang mas may malaking effect ay si fluoride. Okay? Kasi less yung tendency ng formation ng barium hydroxide. Okay? Pero yung formation ni HF, mas mataas. Pero ano yan, based pa rin yan sa Ka value, KSP values, etc. Okay? Pero kung titignan natin sa part na to, since possible yung production ni HF, ano siya, it will push the reaction forward. Okay? And then silver chloride.
Opo.
If it reacts, it forms Ag plus and chloride ion. Okay? Saan siya mas soluble? Sa acidic or basic solution? Now,
Acidic.
for this case, if you'll notice my chloride, pag ito nag-react sa H+, what will it form?
HCl. Ay,
What will it form?
wait. HCl pala. Strong acid.
So, this will not happen.
Naloko po ako dun.
Okay? Hindi siya mangyayari. Kasi, HCl, strong acid. Di ba gusto niya completely dissociated siya? So, ibig sabihin, hindi makukuha ni H plus si chloride. So, halos walang effect si H plus para sa solubility. Halos, right?
Opo.
Kasi definitely, hindi rin naman mag-react si H plus kay silver.
Opo.
Right? Ang pwede mangyari, si silver ion mag-react with hydroxide to form insoluble silver hydroxide.
Opo.
Tama? So, magpe-precipitate to as solid. Ay, wait lang. Silver hydroxide, joke lang, sorry. Mali din ako. Silver hydroxide is soluble. Kasi ang insoluble silver lang ay chlorides, bromides. Tama ba? Is silver hydroxide soluble? Let's check.
Opo.
Na-check mo?
Chinek ko po. Parang walang lumalabas. Dissolves in...
No, it's insoluble. Silver hydroxide is insoluble.
Sayang. Ano po siya? When you find a way but then it's really insoluble. Talagang ano po siya, it doesn't want to dissolve.
Okay. So, notice na insoluble siya. So, in the presence of hydroxide, it can react with silver to form this precipitate. So, magpe-precipitate siya sa solution. So, pag nag-precipitate yan, mababawasan yung silver ions. Tama? So, dahil nabawasan, magpupush to forward.
Opo.
Now, saan mas soluble ang silver chloride? Sa acidic or basic?
Neither, maybe. Or baka basic. More pop sa basic. Pero,
Baka or basic talaga?
ano po sila it doesn't want to dissolve pa rin. Pero, kasi nakita ko po, AgCl dissolves in ammonia eh. So, it wants to dissolve in basic talaga. Tsaka just by logic po, even if the AgOH won't dissolve in water, it's sort of, at least the AgCl itself was removed.
Yes. Actually, for that, I want to emphasize na ang concern natin dito is the solubility of AgCl. So even if madagdagan yung precipitate, but it is in the form of silver hydroxide, still it doesn't, hindi pa rin siya sa silver chloride. Okay? Ano pa rin yung effect niya sa silver chloride? It will somehow increase the solubility pa din. Right? Kasi nababawasan yung silver ions. Tama?
Opo.
Okay. And actually, very common way to dissolve or to induce the dissociation of silver ions is by addition of ammonia. Okay?
Opo.
Kasi si silver ion can react with ammonia to form a complex. This is a silver amine complex. Itong complex na to, this is soluble in water. This is highly soluble in water.
Yay!
Okay? This is a silver amine complex.
So
dahil
silver wants to dissolve in
yun
water.
yung reason kung bakit nakita mo na ginagamit si ammonia para ma-dissolve yung silver chloride. Okay? Kasi magpo-form yan, sobrang ganda ng formation ng silver amine complex. So dahil doon, mababawasan yung concentration ng silver sa product, so mahihila niya yung equilibrium forward. Okay? So tataas ngayon yung amount ng silver chloride na madidissolve.
Tsaka may tanong po ako Di ba po yung silver bromide para rin siyang silver chloride in a way.
Yes.
So essentially, bakit po why do people who vote a lot kahit na maraming beses po kasi every 6 years. Pero sa mga iba pong countries, minsan po, every 8 years. Sa Russia po, kahit
Yan,
since
why do people,
So,
Sorry, yan?
why do they still get Algeria? Kahit na after so many years pala po sila, will they get to vote again? Magkakaroon
Sorry,
po
hindi ko na vote?
Opo, yung stamp po nila, diba, lalagyan po ng indelible ink? Silver bromide po yun eh. So, why do people still develop Algeria kahit na more than 6 years or longer pa po yung elections?
Why do people develop, Algeria. Ano yun? Ano siya?
Overdose in silver, kahit na highly insoluble yung AGBR, tsaka ang tagal po ng voting time.
Actually, previous case yan, as in super tagal na niya. Kasi definitely ngayon walang ganyan. And in the recent years, definitely walang ganyan, right?
Opo.
So yung frequency ng voting during that time, I'm not sure. And kung gaano kadami yung ginagamit nilang amount, hindi rin natin sure. Okay? Kasi may mga ganung factors eh. Maybe during that time, they have no idea on what is happening. So baka yung preparation ng solution, they might add like a little or medyo sobra siguro yung nagagamit aside from or instead of lower concentration. Pwedeng mga ganung klaseng reason. Although I'm not really sure kung ano yung reason. Okay? Pero currently hindi na ginagamit yung silver based na Usually ang ginagamit lang na indelible ink ay anong tawag dito? Mga inks na lang din. So organic based siya at hindi na yung silver based na ions.
Opo.
Okay. So yung for that case, actually I'm not sure, hindi rin ako ganun ka-familiar dun sa na yun, condition na yun. Pero I think maybe ang factor is yung amount, yung concentration kung paano nila pine-prepare yung solution, ganyan. Kasi baka mamaya wala silang idea, sobra-sobra pala yung nagagamit. Diba? Clear ba? Is that clear?
Opo.
Do you have questions?
Wala po.
If wala, then actually, we will do our practice set.
No! I've been fooled. Opo, okay. This is the moment of truth.
Pero ano lang naman siya, sabay naman natin siya sagutan. Okay. You have your copy na, no? Nung ano,
Opo.
questions. Okay. Now, let's go for number 1. Ito, mabilis lang to. Arrange the following order of increasing acidity.
Opo.
Sige. So, practice exercise for ano na to, para sa'yo na tong questions. Ikaw na magsasagot.
Oh no. Okay. Ah, saan po yung...
So, ano lang to, we have one set here, number 1, and another set here, number 2. Sino lang dito ang may pinakamataas na acidity? Without looking at values, baka matignan mo yung mga Ka values. So, mo tignan yung Ka values.
Daya. Yan po yung daya. Talagang ano po eh. A. As is? Kasi parang gano'n naman po eh. As is na lang. Okay, I will mag-open.
Yung recording.
Hindi pa na-pause na po. Muntik na po yan. Muntik na po yan. That was so
Okay,
close to
okay.
almost stopping. Buti nag-pause lang po siya. Ay, sayang. Hindi po ako maka-share screen. Oh, no. Sayang. Ay, mag-share screen. Naka-ano po, host disabled, participant screen sharing.
Okay. Mag-screen share ka ba?
Nag-try po ako mag-screen share.
Pero kailangan mo ba?
Opo, gagawa po ko ng, parang isang ganun lang po, parang whiteboard.
Okay, 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 okay. Ayan. Maybe you can try now.
Alright. Ayun. Yes. Nakita na po?
Yes.
Ayaw niyang ulitin. Good. Now it's time for the... Nawala yung stylus. Ano ba? La. Ayun. Ayun. Okay. So, ayaw pa na magsulat. Hello? Hello? What? Wala. Walang charge. Wait lang po. Wait lang po. Wala pong charge yung screen. Yung stylus. Kukunin ko lang po yung charger. Yung charger para sa yung graphic tablet. Charging point. Yes. Okay. Wala na po akong malagay na port para sa USB. Talagang why is everything working against me? Yun. Yun, yes, charging. Finally. Hopefully po makaka-share screen na ako. Yay! Gumagana yung stylus. Okay. 1. Actually po, I'm not sure about B because I actually do not know what the actual ano po dapat yung ano po talaga dapat yung order. But basing from what I think and what I know so far. Ah, actually po, yung sa two, hindi ko po nasagutan because I do not know what na, ano po yung sabihin ng what percent of the aspirin is in the form of neutral molecules?
Sorry, ano ulit?
Ano po yung what percent of aspirin of the aspirin is in the form of neutral molecules?
So what do you think it means? Does it mean?
I have no idea. Hindi ko alam po kung yung ano, yung acetyl salicylic ba po yung ano na po yung conjugate base na po ba yun or
Ano lang to? Di ba just remember if an acid dissociate, you are just taking out the H, the ionizable H. Yun lang yun. So kapag tinanggal mo siya, the oxygen will become -1. So yun yung ionized form. Yung neutral molecule is when H is still part of the molecule. Yun lang.
ano, I've been, I got bumped. Iniisip ko po for about 2 hours po eh. Nasagutan ko na po lahat. Tapos 2 hours pa parang, what could this mean? And then it turns out pala,
Ano lang yan?
it just
That's
means
just another way. That's just another way of saying na you have to calculate for the unionized fraction of the aspirin molecules.
it just basically means po na I had to find the ano po not dissociated. Okay, now I have to figure
Yes.
out the molecular formula without looking.
Ano lang yan, at least para ma-familiar ka with how they construct the sentences. What's that?
Naano ko po yung, I'm deciphering the molecular formula. 1, 2, 3, 4, 5, 8, 8. Okay. Okay. I think. Pagka nagkamali po ako dito, it means it's the downfall of humanity. Marahimir ko lang na nakalimutan. 9 pala yun. 9.
Or parang C8,
Actually,
9.
I do not need to know. Wait, what if, kasi ano, acetyl salicylic din. So, acetyl is, what's acetyl? I forgot what acetyl meant.
Hindi mo okay lang. For this case, actually, you can just write it down as HA. Kasi, ano lang naman siya, it's a monoprotic acid, right? Pero yung formula, I think it's 1, 2, 5, 6, 7, 8. C8, parang C8H9, di ba? Parang baliktad yung pagkakalagay mo sa 8 and sa ano kanina.
Ano na po ko, I got stolen.
Diba 8 carbons, there are, okay, ano ka, familiar ka ba with organic structures? Joshua? Familiar ka na with organic molecule structures?
Maybe, but not. Because all I know po about organic structure, benzene ring, and then skeletal formula, that's it. Wala na po akong alam.
Okay lang. Kaya okay lang, for at this point, okay lang kahit hindi mo makuha yung formula ng aspirin. Pero, based on the structure, it is C8H9O4. Ay, sorry. 1, 2, 3, 4, 5, 6, 7, 8. C8H8O4 pala. C8H8O4.
So, C8, bro, nawala po yung ano. Tama, tama,
So, bali
tama.
H, H, C8, H7O4. C8, C8. 8 lang ang carbons.
Ah, kasi 6 po, diba? 66 po yung carbons po, diba? Tapos, may carbon dun sa may, yung sa may parang ketone pa yung itsura po,
Ah,
pero,
okay. Sorry. Ako pala yung mali. Oo nga, no. So, 9 carbons. Tama. 6, 7, 8, 9. Yeah. Sorry.
abo.
So, HC9, H7O4.
Actually, it's kind of frustrating because mm, na
Hello, Joshua.
something happened po sa computer eh. Parang bigla
Nawala
nag-crash.
ka.
Wait lang po,
Okay.
hanapin ko po kung may nangyari sa... Ano po ngayon na? 03? Kaya ano? What could have happened? Love that. Something, the computer crashed.
Sige, okay lang.
I-merge ko na lang po yung mga video. May nangyari po sa ano eh. Hindi naman po siya nag-off. Yes. Bigla na nag-ano po siya eh, yung, ngayon po, di ba wala na po yung blue screen of death, nag-black screen of death. Patay ako. Ala, nawala lahat ng solution. No. Anyway,
Using desktop
at least,
PC ba?
konti pa lang po yung nasulat. Okay, good. Hindi po ko hindi po ko hindi po ko maglatampo.
Are you using desktop ba?
Laptop mo na ano na
Okay.
siguro na ano po siya, tatanggal ko po yung mga unnecessary files ko mamaya. Kasi parang na-overload na po siya. Kawawa na lang.
Your arrow.
Ano pala siya? Yung just lang acid. Me after miscalculating the moles of nitroglycerin. So the entire laboratory exploded. Ah. Okay. I still don't never know. I do not know. Milligram. Something. Mole. Brown. And, kaya ano pala po kayo, medyo, I'm, nasira.
Stretch na.
Okay, good. Oh, technology. Grams. 1 mole, ba't ununiform yung pag... Minsan po pag gusto ko pong articulate yung 1 ko po, articulate ko po siya. Pero pag hindi, straight line lang po siya for some reason.
And gusto ko pag kung ano yung nasimulan, yun din yung iba.
Abo. 1.00. Sobra pala po yung inalat ko na space. Kahit na very exact po. Yun pala. Divide by. Nice. So, whatever this is. Something.
Pwede ka maglagay equals A or B or you can assign variables.
Delta. Parang, commemorate na. Okay, lalagay ko po yung something. May idea po ako. Paano pa po? Ganito pa po yung pag-ano ng delta? Parang medyo na po ko eh. Delta. Delta.
Tama naman. Yung iba, ganyan lang din magsulat ng delta.
Ayun. Okay. Meron pa lang noise na. pH of 2. Bakit po yung pH po ng stomach acid lemon? Bakit po yung pH ng stomach acid lemon lang?
Sorry, ano ulit? Hindi ko naintindihan.
Bakit po yung pH po ng stomach acid parang lemon lang po?
Hindi naman siya, actually, for that, hindi lang kasi yung acidity yung nagde-degrade ng substance. There are also other gastric enzymes that helps digestion. So, wag mong ilang yung pH 2.
I forgot what.
Kasi pH, pH is just based on the H plus concentration. It's entirely just based on the H plus concentration. Again, it doesn't directly tell us anything about yung corrosion or something, right?
Abo. Yung I hope ko po magkakaroon ng isa pang variable na kailangan. So, may pang mahihinga. Nanap pala to. Tapos divided by yung delta. So we're looking for
Right. Okay. Buti kinorect mo. Kasi naka-over-X kanina eh.
naka-OCD po eh. Find X somehow. Dissolved in a full stomach. Volume is 1 liter. Okay, good. So, lahat pala ng lahat po ng makuha kong moles, ano na po yan? Yan na po yung molarity.
Yes.
KE. Equals, I forgot. Na. Something must be wrong. No, it won't work. The pinnacle of depression when you have to clear the shift solve when you literally wrote everything out. Parang sobrang OA naman po. Anyway, parang it's hard to believe. Naging 4.9.
Joshua, for the number of moles, 3.8, yung nakuha mo, 3.871 times 10 raised to negative 5.
Tigas po ng
Diba 3 to
yung storage tipo biglaan ang tigas. Ano nangyari?
I'm getting a different value for the number of moles.
RIP. Mali lahat. 2 times 325 divided by 3.607.
Okay, sorry. Ako. 2 tablets pala. Okay. Sorry. Ako pala yung mali. Tama siya.
Buti po sinuot ko po lahat ng lumabas na decimal digits. So, kaya masisira po yung buhay ko po.
2 times 325. 325. Parang nasa 3.6 something yung nakuha ko. 3.607.
89 po.
For the number of moles, 3.60789 times 10 raised to negative 3.
Ah. Ito nga po yung sinasabi ko po sa inyo eh. Hindi po ako pwedeng maging yung professional kasi pag pinahandle po sa akin mga dangerous chemicals, may may mag-mutate.
Then ano lang yan, you just need practice. Madali lang makorrect yung ganyan.
Hopefully.
Times 10 raised to negative
3. No way! Imposible po to. This is very shocking. Bigla po my world shattered. Oh no.
Hmm. What is the value of x?
Something times -5. Looks suspicious.
I don't know. Iba yung nakuha kong value ng x.
Dito po yung betrayal of the shift zone.
Hmm. Wait lang, baka ako yung mali naman. Times n raised to -3 minus x times 3 times 10 raised to -5 equals 1 plus x times x. So, yeah, okay. Nakuha ko na.
Pero if this is real po, which is probably is, kasi it's almost impossible po na magkakaroon bigla na 0.999 ay 0.997. Grabe po yung ano.
Okay. So, that's correct.
No. Talagang ano pala po, the medicine needs improvement.
And other question for this is pH lang naman, di ba?
Opo.
So, how do you solve for pH?
Wala naman pong hinanap actually po na pH eh. Nilagay lang po, but what percent of the aspirin is in the form of neutral molar?
Okay. Ibang question pa rin naalala ko. Yes, so yun lang pala hinahanap. So, meaning for number 2, 99.7% still undissociated aspirin molecule. Okay?
Opo. Where's the...
Kasi number 1 answer mo hindi natin na-check.
Wala. Saan pa yung free real estate? Naghanap po ako ng free real estate. Saan na po siya tuloy? Na po tuloy.
Okay. So ano na? For number 2, this is correct. Okay?
Shockingly correct. Yay, free real estate.
Okay. Now, so tignan natin First, letter A. Okay? Your answer for number 1, letter A is correct. Okay?
Yay.
So, what is the reason for this? Actually, yung anong reason mo dito? Bakit ganito yung trend?
Because sa una po, pag parang lumalaki po yung molecule, Lalo na parang humihina po yung bond.
Yes. Yes. Actually, it's more of the bond distance between the central atom and H. Okay? And diba, if you remember, the longer the bond, mas unstable, mas madali siyang paghiwalayin. Tama?
Opo.
So for this case, the largest atom among oxygen, sulfur, and selenium, the largest atom is selenium. Okay? Hello, Joshua. Are you there?
Opo.
Okay.
Ano, nasisira-sira po yung nangyayari po somehow.
Okay. Now, dahil mas malayo yung distance between selenium and hydrogen, mas madali siyang mahiwalay. Right? And that's the opposite naman for water. So this is correct. Clear? Is this clear? Hello?
Nangyari po.
Hello?
Hello po?
I mean, I'm asking if clear ba?
Opo.
Okay. For letter B, may mali doon sa pattern. May mali doon sa arrangement.
Oh, no.
Okay. Now, what do you think is the significant factor that determines acid strength for this case? To differentiate the given molecules here.
Of the deprotonation.
Well, actually, for this case, you have to look at inductive effect based on the presence of electronegative atom. So if you'll notice, it's just a central atom with the oxygens, and then the hydrogen are connected to hydrogen, to oxygen. Tama? Yun yung structure ng mga yan eh. Now, the higher the electronegativity of the central atom is, mas malakas yung pull ng electron density inward. And therefore, weaker yung OH bond. Clear? So what you have to actually consider is the electronegativity of the central atom. The higher the electronegativity, the weaker the OH bond. Can you imagine the structure? For example, H3PO4, you have phosphorus on the center. Bonded to phosphorus are oxygens. And then bonded to oxygen are hydrogens. Tama? Ganun din for the other molecules here. You have sulfuric acid, sulfur, and then oxygen, and then bonded to oxygen are hydrogen. Kapag mas electronegative yung central atom, mas weaker yung OH bond. Kasi hinihilan niya yung electron density inward. Clear? Okay. So what do you think should be the proper arrangement?
Baliktad. Yun lang po. Baliktad. Naka-depend.
May open kang periodic table? May naka-open kang periodic table? Sino ang may central atom na least electronegative?
Electronegative. Arsenic pala. Ayan. Malapit yung phosphorus.
Okay, final answer?
Opo.
Okay, that's correct. Okay.
Opo.
Actually, the moment you see the given molecules, actually dapat you should think na sulfuric acid should be the strongest eh. Kasi unang-una, si sulfuric acid is a strong acid, right?
Opo.
Okay. So now for letter B, remember the reason here is inductive effect. You have to consider the distribution of electron density. Okay? Yung electronegativity atom, hinihila niya inward yung electron density. Is that clear?
Opo.
Questions? Do you have questions?
Wala po.
Okay. Now for the remaining three problems.
Ito na. Okay. At least ito po, meron na po akong nagawa na full po na solution.
Okay, good.
Kung mali po to iyak. Sabihin, talagang kahit na pinaghirapan talagang wala. Actually, mali po yung nakasolve po na arrow eh. Buti na kaka-notice ko pa lang po.
Remember, water is part of the reaction kahit hindi na natin siya nilalagay. Reminder lang.
May ghost na tubig.
May gano'n, may yan dyan.
Kawawa naman po yung tubig. It plays a significant role pero hindi siya pinakonsider. One prayer for water. Alright. Okay. Game mode.
Good.
K.
Okay. So for this case, this is a base dissociation reaction. You are given sodium cyanide. Remember, sodium ions just spectator ion. What actually participates in the acid-base reaction are the cyanide ion. So this is the dissociation reaction. This ice table is correct. Okay? And yung important part dito is what you have to use for the equilibrium constant is the Kb value for cyanide. The given in the problem is Ka for hydrocyanic acid. So you need to get the ratio Kw over AA and Ka, and this is correct, 2.05 times 10 raised to negative 4. Now solving the equilibrium expression, this is correct for the OH minus concentration. Although this is concentration, so you have to write down the proper unit, which is
Abo.
the proper unit for the concentration is
Molar.
okay. Yeah. Okay. So that's concentration na. So be careful when writing concentration. It has to be
Pero po
with the
na-refer po
unit.
ko. So,
Okay?
abo.
So getting the negative logarithm, you get POH, and from pH, you can get pH. So the answer is 11.01. This is correct. Okay?
Abo.
Okay. Correct.
Hmm.
Number 4.
Kaya palang nababambuso po ako. Hindi ko po nakikita na wala palang next page. 4. Use 2 ice tables. So, partner. Tan 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 tan. Tan 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 tan. Tan 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 tan. Ay. Ako na mo din hydrogen.
Actually ako, I would prefer na if you write down H3O+, you have to also write down water. Kung walang water, just simply use H+. Pero it's a matter of preference lang naman.
Me after picking the UCV output. Pinataba po yung H plus kasi parang ay now I can make you sing. Ay, yun lang. Umobra. Ayaw niyo po mag-sing. Ay! Wala, hindi
sobrang laki niya mag-adjust actually.
Si Tirelli.
Maybe you have to write it down again.
Save me undo. Grabe. Nalito na po siya.
Writing it down again is easier.
Ay. Parang baliktad.
Charge of the oxalate ion.
Me after forgetting basic. Me after forgetting basic. Oh, yun. I forgot the
Good.
basics. Idea. Since there will be two variables.
Alam ko na yan. Kulang na, yung table mo. Equilibrium row. Yung equilibrium row ng first table.
Wait lang mo. Lowercase. Rin po siya eh. Okay, good. Yay! Pero mukha siya. Gagawin ko siya partially. Mukhang decent. Yay! Okay.
Omega yan, di ba? Ay, omega. Ano to ba? Theta. Theta yan kapag may ganyan.
Katulo po yan. Theta uppercase. Ba? Oo nga po na.
Kasi Omicron is just O. Same lang siya talaga.
Wala.
Kaso hindi siya magandang symbol. Kasi tawag dito, maano mo siya with zero.
Beta.
Yan, better. That's better.
Yes, okay, finally. Inner peace. Oxalic acid.
Okay, now I have to figure out what to do. The pH of the solution. I need to find out the H plus. Okay, good. One. Well, something. I forgot. Whatever this is.
Product over reactant.
Squared.
Okay.
Nagka-brain fart eh. So I have to pub. Me po after using the shift solve function for the 598 times.
Suki talaga ng shift solve ang acid-base equilibrium. Ang equilibrium in general.
Opo. Bakit po? Pero, it's finally positive group. Oh. Everything just got worse. Let's hope po the Casio won't have a heart attack. It looks like a mathematical equation.
Okay, so what are your final answers?
My first final answer, and then the other final answer is still obscure. The oxalate, whatever thing, something. King. Ito na pala yung oxalate. Yay.
Okay. So pH is 1.736, around 1.74. Okay? And your answer for the oxalate concentration, what unit?
I forgot.
Molar. Okay? So these two answers are correct. Okay? So the equilibrium concentration for oxalate ion is 6.36 times 10 raised to negative 5 molar. And then for the pH of the solution, it's 1.74. Okay? Good. Very good. Actually, for this case, for the pH calculation, walang effect yung walang effect yung second dissociation. But we still have to calculate it kasi we want to know the oxalate ion concentration. Okay? Question sa problem na to.
Wala.
Okay. And then final question, number 5.
Final question. Impossible kasi kakaturo pa lang po eh. So,
Kaya yan.
ito po ang psychological torture. Ito pa yung ginagamit ng Germans ng World War II.
Ano naman, I'll guide you naman if ever medyo malito. So first, calculate the solubility of lead chloride in pure water.
Pure water, impossible.
Solubility in pure water, given the KSP?
When when the ice table has no more reactant. Yay.
Pero you still have to write the full reaction. I mean, you still no. Wag ganon. For solubility equilibrium, you always have to write the salt. Okay? And your arrow,
Why do I always keep messing up the arrow? Lagi ko po kala na complete lagi. Ang layo ng class. Tapos na lapit ng tubig. The proof of no more existence. Ano yung original?
No, okay lang, okay lang, okay lang. Huwag mo siya sobrang i-blur. Kailangan makita yung full, ano.
RIP. Original, nothing. Oliver. Sabi ko na ano po yung mga yes. Tapos ito. When I finally get something right. Yay! Ganito na pala siya.
Oops, 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 oops. Double check the equation. Start by writing down the equation or the terms individually.
Galing.
No, 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 no. Saan yung squared?
May mali akong ginagawa. Parang ano po, parang ano po eh, I'm shooting blindly. Tingnan mo ako.
Oo nga. Kaya, actually, that's the reason why you have to write down the equation. Para hindi, hindi basta mix and match.
Kasi, maxi ano? Oh, I forgot the formula. I forgot the formula po sa... I realized there were formulas already. No! I fall into the trap of the fallen of the trap of the manual hard work labor.
Ay, okay lang. Okay lang yan. I still prefer yung manual calculation than just directly using a memorized formula. Kasi, when you do it manually, it proves na alam mo yung step, all the process, and you know how it works. Okay.
Mole per liter, Molar.
Mole per liter, molar, that's correct. Okay, good. So the solubility of lead chloride in pure water is 0.0162 molar. Okay.
Big.
Now, what about question letter B?
0.016162 big meter. Question number 2. In a solution that is, I cannot understand. In a solution that is 0.0050 molars in lead nitrate?
Yes. Meaning, lead nitrate is already present in the solution. And then you want to dissolve your lead chloride. What will be the solubility of the salt in that solution?
Common ion. Sayang wala pong copy paste. Anyway. Present na. that mad scientist who added the lead nitrate so he could make my computations even harder. Mm. No, I need manual computation. Oh. I'm doomed. But ito po yung ano po, itsura po ng life ko po pag na-take away po yung calculator. Wala na pong buhay. Ito po yung nakakalungkot po, wala talagang 0.162 pa rin, 0.0162 molars pa rin po. Oh, all of that hard work wasted for nothing.
Will it be still 0.016?
Hopefully not, para hindi po masayang yung oras.
Pero based on the concept of common ion effect, do you think it will be almost just the same?
It must be very different, halos. Ayun, tama.
Malaki ang effect. Malaki ang effect ng common ion talaga.
Ano po, why did the scientists have to put lead nitrate when he could have put sodium nitrate or another nitrate?
Yun eh.
The blue curtain. Tang, tang, tang. Tang, tang, tang.
How did you get your answer?
I don't know. Shift solve.
Shift solve?
Abo.
For this case, actually, ano dapat yung mangyari sa solubility? Should it increase or decrease?
Decrease.
Okay. So, answer is 0.014. Wait lang, let me double check.
Or
So it's
sobrang laki naman po.
1.0.
Ang liit po na nilagay ng lead nitrate tapos biglang masisira po yung solubility. Dapat po gagawin na po yung tubig na po, lilis na po ng lalis na po na lead nitrate, ang konti-konti lang, hindi po makita ng kulay. Para dadagdag po yung sobrang laki po na effect ng common ion effect. Hindi na po madidissolve yung
Actually, yung 0.05 is slightly. Okay. Answer is 0.01469. That's correct.
Yay!
Okay. Is this clear? Okay. Do you have questions? Any questions from the problems that we solved for this topic?
Wala po.
Sure. Any other question para sa chemical equilibrium, aqueous and solubility equilibrium, acids and bases?
Bakit po why is the acid and bases so much bigger than general equilibrium?
Nako, yung ganun talaga. Madami kasing kailangan i-consider. At actually, general equilibrium on its own is also a big topic. Pero yung acid-base equilibrium is just a portion of the topic. Pero dahil special case siya, there are also other considerations that we have to think of kasi nagbabago na yung system, etc. Okay? Pero clear naman? Is everything clear? Okay. So, sige, it's already 9 o'clock dyan. So, if you don't have any more question, then that ends our discussion for aqueous equilibrium. Okay?
Okay.
So, yun. Thank you, Joshua, for attending today's session.
Okay po.
Sige.
Okay po.
Thank you. Wala nang question na. Everything
Wala na po.
clear?
Wala na po.
Okay, sige, sige. So, kung okay na, then that ends our discussion here. Thank you, thank you.
Bye-bye po. Sayonara.
Bye-bye. Sayonara.